Good morning, everyone. Thank you for coming today. As you can see on the screen, my name is Marcus, but everybody call me Mart, and today we do what I like to call a feel-good security talk. The main idea here today is to talk about cloud security and wildlife. Why? Because one day I was quite sleeping, and I quite love otters. We're going to talk a lot about otters and monkeys today. And I think like everything that we think about cloud security got a thing with the wildlife. And for some reason, the people who organized the summit think the same because he did accept this talk. So pretty much, who am I? I kind of like this order. Like I always try to present myself. My name is Marcus. Everybody call me Mart. I have been working security for the past 10 years. Science University, from European projects from Brazil, then to consultants like Control Plane in the UK, to e-commerce platforms, and then right now I work with Bitso, which is an exchange for crypto. And pretty much, I from this little town in Brazil called Campina Grande. It's quite lovely, and then we come a long way to get to here. And right now, I live in the lovely Peak District in Sheffield in the UK, which is quite strange for a Brazilian to say that the UK is a good place, but it's nice. Thanks to my sponsors, I'm here today because of the CatStyle team and the Bitso. Bitso is a crypto exchange, and CatStyle is quite nice. We work a lot with Web3, and then we got lovely talks in DEF CON about, okay, you have a company, and then a state start to attack you like North Korea, so how do you deal with that? And besides of working offensive security and think how do you protect crypto and make acceptable for everyone, we try to do this kind of ludic talk that we quite love, getting two subjects that maybe don't make sense, but we want to try to have a difference, oh, they make sense together. So that's a CatStyle. It's kind of a royal bird from the Mesopotamia, or pretty much the Latin America. And I think the most amazing thing about the CatStyle is if you go to the mythology of the Mayans, it's a symbol of freedom. And it's quite amazing to be in the Open Source Summit with a bird that talks about freedom. So going through, we have some disclaimers today. You're going to see a lot of images AI-based, but this image is based on the cordel. Cordel is something from the northeast of Brazil, which is my region just there. It's pretty much a type of art that I want to put the animals. Things is quite important. Every single piece of code is quite functional, but we need to simplify to be more ludic. So the main idea here is not to have the code functional. The main idea is to have the idea of how you can teach people about Falco and other tools talking about security and showing the code. The idea of the evolution of this talk is to become a workshop, so it's to have some labs in the future, next 2 or 3 months, open source so that you can test the tools and see how to teach people from a security artist program or so on about security with animals. And then a disclaimer, this talk focuses a lot in Kubernetes, so if you see on the schedule, we talk this intermediate talk, not because it's difficult, but just because we talk a lot about Kubernetes. We think that you hear the audience understands the namespace and so on. Okay, so we got quite a big agenda. We're going to talk about 9 animals today, and the main idea is to do this kind of analogy, how we can talk about animals, how we can talk about security, and how we can show these examples that make sense. If you have any questions, I will try to hush up and do this in around 30 minutes, and then we can discuss more and talk about the future as well. So pretty much, why wildlife? Why I wake up one day, think about others, and I did decide to do a talk about cloud security and the wildlife? It's pretty much because we have an evolution of animals. And I quite love this topic. I am computer science by formation, but I quite like the idea of how smart animals are. So think about otters and monkeys. These two images is quite amazing. Otters got a favorite rock, and they use the rock as a tool. So pretty much as everything that we do are cybersecurity engineers, SREs, platform engineers, is how we have our rocks, how we have our favorite rock, and pretty much how we treat with that. And monkeys, they got this amazing thing, they know trade-offs. Everyone knows this kind of joke of what's the difference between a senior software engineer, or they understand the trade-offs. And we got this case of monkeys that start to understand the value of things and how to trade. So pretty much, do you trade security for velocity? So how can I do that? And they want to show this kind of analogy. So pretty much, they know how to adapt. They understand how it's changing the environment. And when you think about migrations, when you think about new technologies, when you think about this whole hype with AI, we can figure out about animals, like how do you adapt, how do you evolve. The second thing is they need to migrate for the survival. One example that you're going to use today is flock of birds, but when you need to do a migration because your cloud provider is just charging a lot, or you want to go to on-premise because of security concerns, that's pretty much, we need to do that as a company, as people, to survive. So this is quite interesting as well. The third point is collaboration. If you don't collaborate with people, we are in the Open Source Summit since 1991. The main idea is how do you collaborate to be better, how do you collaborate to do more things. And then you are only not safe by yourself. How do you create more layers? How do you do more things to be more protected? And pretty much to understand that every single layer protects against one different thing. And last but not least, early warning systems. Every single group of animals, from humans, if you think about tremors and everything, you have this early warning about, oh, you have a tremor coming. You have meteorological warnings. Animals got the same. We talk about birds that understand that a tremor will be coming. Or when you have these tsunamis, you see fishes, moving around. So that's how you can get this kind of example and go to cloud native. And if you look at every single point that's in both, this quite sounds familiar, right? If you think about cloud security, it's pretty much some of the pillars. We are talking about resilience here. We are talking about early warnings. This is goal observability and so on. So that's pretty much how we can start to do this analogy between the things. And okay, so we got 9 animals for today. We start with chameleons. The main thing with chameleons is they are quite adaptive. So pretty much they change colors to match the environment, but they follow rules. So you will never see a chameleon going bright orange. But they try to be okay. If I have a predator, if I have something coming, if I change in my context, I will change colors, which is pretty much that idea here today. So how do you change as a chameleon? How do you think about policies? And pretty much how do you think where and when you need to change? And that's the idea of cloud security. Think about a chameleon. If you think about Kubernetes, I have different stages of production, of dev, and so on. So how, as a chameleon, I can be with the context aware, I can understand how I respond to threats, but pretty much understanding my rules and understand how these things goes. And then we have the first piece of code. Pretty much we have a open policy agent with Rego and how this changes. If a person is trying to create a pod or something inside of a production environment, okay, why you try to create that a root? So you need to be a known root by default. So the main idea is, like a chameleon, you adapt to the rule. You understand the context, you see what happened, and then you move. And pretty much, if you have different rules, as the chameleon, you're going to have different colors. And every single color will go on one of those. And it's pretty much how do you evolve and how do you go through this. And that's the kind of idea of, now we understand that animal analogy can be quite useful with Kubernetes, and think that you have a team that's trying to understand this amount of thing. I love Manifest, I love YAML, but I don't know how to teach that in a way that makes sense. So if the creation of analogies and try to make things more close to one thing that's not so close as animals, but again, as you guys are here, because nobody goes like, oh, I want to hear about others. But the main thing is, this brings your attention. So it's how do we evolve that and we create these examples that people will like to understand. And, And then we go to our second one, bees. One thing that we talk a lot is the hive mind, about how bees think and how they adapt for the what, the thing that's happening right now. And the main idea here is talk about one tool that everybody is using. Think about kernel as eBPF. So if you will be adapting, and I love this battery pump, if you think about a bee, they understand who is the queen, they understand how the hive moves, and pretty much they understand the threats to the hives. This go to against hornets, this go against humans as well, but pretty much is how they work in different time zone, in different environments, and pretty much understanding what's happening on the surroundings. And when you have that, is again, what does have to go with cybersecurity? What have to go with cloud security? Pretty much, you need to adapt in a runtime, right? If you are running a model, if you are running things that are critical, you don't have the hope to wait. You don't have the possibility to understand that this will happen like 5, 6, or 7 minutes. You need to take action right now. And that's what I love about that. This is quite a bad slide because there's too much information. But the main idea is you have a scout B, and then you have a response for the hive. When you think about the eBPF, you are thinking about the kernel level. So you want one thing to react fast, but you don't want to stop the whole system. So this analogy here breaks into 2 parts. You have the eBPF adapt to the runtime behavior. So okay, like a bee in the environment, why this person is trying to access this thing? This syscall was not expected. Why the user A is doing that? And pretty much the scout B will mount, okay, this is quite strange. After they understand that something's going strange with that PID for that process, you start to have a change. So then you got the adapted to high response. Okay, that's quite risky. Why this process that never access this layer of security is trying to get there? And pretty much this shows how bees think, even because the logo and the mascot of eBPF is a bee, but the main idea is you got this hive response. So if you think about chameleons, if you think about bees, we will see they are quite similar, but a little bit different, and that's one thing that we want to explore today. So going back to our bee, it's pretty much about runtime adaptation, threat detection, and hive awareness, right? If one thing is happening in one part of my code, this can affect other bits. For more that we think about isolation, for more that we got things like inter-XGX and enclaves and etc., we need to understand we have microservices, right? We have layers that communicate with each other. We have models that communicate with each other. So how I can use my bees, how I can use eBPF, understand how the process is going, and pretty much detecting the process injection the moment it happens. And the most amazing thing is, we talk about chameleons, we talk about bees. But they sound the same, but they are not. If somebody here talk about threat modeling or other things, we normally have the 5 whys. But the main here, I just want you to think about 3. When you think about the chameleons, they need to blend and change on the environment they don't understand. So pretty much, if I'm doing that in that stage environment, I need to put that rule. So they understand the rule of the games. They be not, they me, they react for the what. So this thing's happening right now. And this is the kind of analogy that we really want to stick with you guys today, because with you folks today, because the main idea is how I can understand the difference between things like OPA, using Rego to write policies, and pretty much with eBPF. Because every single bit in the ecosystem got the value. Every single bit in the ecosystem got the thing they need to sort it out. And then moving forward, we're going to talk about falcons. It'll be fun because we're going to be talking about falcons and birds, but are different things. Pretty much, the idea of the falcon is they got this amazing view, right? I don't have a great view, to be fair, a great sight. But the main idea is you can think as a falcon that you see a threat from the above. They understand what's happening, and they're going to have this really sharp edge thing to move forward and to understand, okay, that's a problem, because they got the context. When you think about animals, you got evolutions of millions, not millions, but thousands of years, and then they start to get the things to respond in a proper way. So if you go to cloud security, it's pretty much, okay, I have this knowledge, I have been training this thing with my threat modeling, with my threat intelligence, so pretty much I have the real-time alerts. I can understand, have a swift response. So if you look about the code, it's pretty much quite interesting thinking about the eBPF one. So we are talking about the what, right? When you use Falco, you have a set of context in the past and set of information that you use to try to understand that. Okay, if I am a B and see quite a different access, are you alarmed? But no, that was one specific case because an incident is happening. So how do you create allow lists and block lists with the Falcon? How the Falcon can understand that they can jump in the lake and get a fish, or they can understand that the energy to do that will not be enough. So that's kind of the analogy that we'll be doing today. And then pretty much is the monitor, right? If you see how a falcon and the group behave, they think about what's happening there, they try to have this swift response, and as you are open the sky, the amount of energy that you take to go down is too high. So you need to be really on point. So think about an incident. The main problem if you got an incident in companies who deal with payments is the time of the thing. So if you lose your energy looking at the wrong point, you'll be lost in time and money. So that's the idea that we got to do the analogy with the falcon, is like you need to be quite precise. And pretty much, think about animals together. The falcon in that case, in the real life, the falcon work by themselves. But if you think about here, you're going to have the mix between the falcon and the bee. So pretty much, think as the BPF as security camera recording. They will check every single thing. They will got the knowledge, and then they will share the information. So, okay, we start to think about wildlife, right? We start to talk about animals as single things, but we need to think until the end of this talk is how they can work together. And again, how you get the layers of every single thing being built up each other. And then we're going to talk about birds. I know that falcon is a bird, but let's think about other type of birds. When you have migration patterns, it's quite amazing. This was kind of the thing I did in the start of this talk is, okay, you now have a really, really big view of, let's say, G-Cloud. And then you want to change, right? Because, oh, good example for 2 days ago. Most of the AI companies are trying to move away from Asia because they have a lot of GPUs, but they are kind of control the market. So, okay, you need to do this quite really big model change. You need to move from a farm of GPUs to the other. So think about flocks of birds is quite interesting because you need to have the thing that makes sense. Doing migrations and doing movement is quite hard. If every single person here do a movement is amazingly stressful. One example that I love, which was from Brazil, I'm from Brazil, so pretty much we have the HSBC being sold to a Brazilian bank, and I was talking with the engineer who did the thing. It was quite amazing because they need to have even helicopters to move the data if anything goes down in the direct links. So pretty much when you think of flock of birds, when you think about migration, the main idea is how you can move your workload, how you can move the cloud, thinking about stuff like security. Okay, but are you going to have some downtime? If I'm working with banks, if I'm working with e-commerce, I don't want to be off for like 3, 4, 5 hours, because right now when you think about e-commerce, we think about following the sun, right? You only do not think about selling in Amsterdam, you only not think about selling Netherlands, you think about selling the world. So don't want to have the downtime. So how I can put some things down and move like a flock of birds. And I quite like the idea of the flock of birds. My region in Brazil is quite dry, it's called the sertão. And then the birds move when they do not find enough food or they start to understand the weather is not going well. So it's pretty much the main thing that we do when we have cloud migrations. We need to understand what's not working for us, or if you need a new tool, or if we need a new build, but pretty much we need to understand what's happening there to move in a proper way. And that's the migrate secret of the birds, right? You have a leader who you move the flock, and then you have redundancies, right? So if one of the leaders go down for some problem, you have emergency protocols, you have multiple navigation systems, and that's what I want to show in that example. I know that's a lot of things, but think about 5 birds in a safe cloud migration. You have a geese migration, and then you have the difference of, if something go bad, you have one worker that can get the place of the leader. So when you start to move, when you do this kind of thing, you need to understand how your code will move, how your infrastructure will move, and how you have the resilience and the substitution in place. And then we're going to armadillos right now. We talk about different layers, but if you think about an animal that was built to be safe against a lot of more strong animals. And pretty much when you think about the armadillo in the wild, you got layers, you got the ways that you can defend, so they roll. We got one thing that's called tattoo ball in Brazil, that's pretty much the one that rolls itself. And then they need to understand how to escape, right? Sometimes, to be fair, the best solution to an incident is to get away of that part, to understand or to isolate the attack in one place, and then dig yourself out and try to get that sandbox that you be stuck on it. And when you think about cloud security, it's pretty much what I talk about, the complete system lockdown, or the multi-layer security, right? So you don't have just one piece of security. You have a lot of layers, and then you start to harden and change your layers based on what's happening, not just on history, but pretty much what's happening right now. And I quite like this diagram. It's quite simple, but the idea is, if you think that you have one application that's on internet, you can think about every single layer of security as a part of the armadillo. So you have the web application firewall and the CDN as outer shell. You have the load balance, and then you have network policies. You have the role-based access controls and so on. So the main idea is you start to create these layers and you start to understand how you can protect more yourself, and you don't want to get to the heart of the database. So that's the main thing with encryption that we are moving. And then it's quite a simple thing. This is quite amazing because you are using other things that you learn. You are using the big brain, that's the Falco, and then the gut feeling, that's the eBPF. So pretty much you start to detect the things, you start to move, and then from that part, you understand the traversal patterns, and then you can move away. And then just move a little bit further, we have the spiders, which is, if I have this lot of information, but I cannot understand how to measure that, on how to use that information, nothing will be useful. So the main idea of the spiders is, if you think about Spider-Man, that's quite a nice example. It's pretty much spider sense and pattern recognition. So how I can get these signals that I got in the past, how I can get this information and evolve to quite important data for me. And the main idea is how I have observability, things like Honeycomb, Prometheus, Graphon, and so on, and pretty much how I have my systems of monitoring in a distributed way, right? If you think about a web of a spider, it's pretty much that, how I start to put this information and so on. We love to talk about AI, but think about AI is how my spider got the powered threat detection, how they got the information to evolve and to move in that direction. And then it's pretty much one quite simple example. Okay, I have the Prometheus on my spider web. At every 15 seconds, I will try to check, and I really want to get my metrics, which pretty much the vibrations in the web. So what I try to understand, why I'm measuring in my web. I have my logs, which the information that will be able to me to evolve and to improve my web. And I have the traces, right? Think about the web. What was the path that the thing follow up? What's the path the log will follow up, and so on. And you start to put more information and you start to put more animals on top, right? Because the eBPF provides the information that the spider web needs. And then we start to think about the things work with each other. And then that's the main thing of the talk today. We talk about otters. And it's pretty much how to stay in connect. I quite love the idea, and every single person saw that picture about others holding hands. And the main idea, we talk a lot about microservices and so on, right? So if you think about a service mesh, if you think about the infrastructure layer, if you think about how to communicate themselves, there's pretty much others trying to survive. One other hold the hand of each other in a lake because of the flow of the river when they are sleeping, they will not be separated. So the main idea here today is, just like others, we're going to hold hands and understand how the currents of the cloud will be able to help us and we stuck together. And I kind of love this example with ISTU. It's pretty much, okay, I have the service mesh improving this hand holding, right? Because the hand holding is quite important because I need to understand the microservices and being together. I need to understand the things, okay. But I'm just saying that if I understand my microservices, if I and hold the hands, this is enough? And the answer is no. If you are sleeping, one thing that you always say is like, is you have kids in the beach, and one kid get the hand of an adult that's not their father or their mother, and they get, that's a problem, that's not my parent. That's the main idea here. We have things like MTLS, that you can guarantee that the order that you are holding hand, the service that you are holding hand, have the certificate, and it's pretty much the trust orders that can join the pods. So the main idea is to show how different things about one good example, which is pretty much holding hands, will be enough to save the environment, to help us, and to evolve. And then I like dolphins, right? There's a lovely book, the Hitchhiker's Guide for the Galaxy, I don't remember the name in English, but we really talk about how intelligent dolphins are. And I like the idea of the pod communications with them, because they use the ecosystem to understand the surroundings like bats and to communicate with each other. So when you think about dolphins is, okay, how I have, if you think about social intelligence networks as a graph, how I have the dolphins in my area, how I have the dolphins inside of the water, and I can understand what's the place that I can go, and pretty much I can understand if that there is a dolphin or it's a threat. And pretty much is how we think about AI, ML, and cloud security, which is a big thing for years now, but how I get the behaviors like dolphins, how I have these echo feelings, how I do understand the echo soundings to have this adaptive security response. And just have a little example of ML code in Python is pretty much, okay, I need to spec the packets, I need to understand if this pod can join, I need to understand what's safe based on the learnings that I have. This is quite a simple example, but the main idea is, if I'm having a person try to say that a dolphin, but they are not a dolphin, how I can understand that, how I can check the patterns, and how I can see if they're in the correct place or not. And last but not least, we have the cows monkeys. I love the idea of cows monkeys for Netflix, and then I'm going to talk a little bit about that. I love monkeys itself. As I told in the beginning, they are really smart, and they understand how to treat with the environment, right? We have really funny videos and cruel of monkeys stealing cell phones in Thailand. They just try to trade by food. So the main idea is they will be persistence, they will adapt itself, so like monkeys are here for longer than us, but the main idea is they try to exploit misconfigurations, they try to see a problem. If you see people backpacking, they just jump in their backs and try to pick one thing, and pretty much when they are doing with each other, there's some videos of monkeys attacking things like crocodiles or leopards just for the fun, just to see how they will react. And the main idea here is we have two types of cows monkeys. We have the cows monkeys that we want to have in our systems, which is pretty much everybody learn about Netflix talking about that. And then we have attackers that you try to be there, get information, and move forward. This is a really bad example, but pretty much you have a cows monkey that you deploy in one region of AWS, and then you expect that some instance will broke. And what's the idea of the cows monkey is, even if they do a problem in your infrastructure, you have the knowledge or you have the possibility of fixing stuff. That's the main idea here. And the bad cows monkey is pretty much, okay, I have someone that's trying to harm, I have someone that's trying to make a problem, they will exploit my misconfiguration, they will try to get money or any other information for my company. And then the main idea here is quite different how we prove ourselves against cows monkeys. The idea that I quite love about monkeys that are really curious, so they try to understand and touch stuff. If you have been a head teamer or if you have been working with head teamers, this is pretty much the same idea. You do a reconnaissance, you try to understand what's happening, you are being curious. So you try to check and move forward. Exactly the idea why you have good monkeys. That's why you have red things inside of the companies. How I can do these attacks, how I can move things in their way that I will be able to, when a really bad actor appears, I will be able to get the information and move that forward. And then, just getting quite off the end of the presentation, as we talk about bees, we need to adapt. It's pretty much think about the bee and the falcon. It's the main thing we want. How you get the information. Information is key. Is how do you evolve from that. We need to understand that migration requires planning. If you think about migration a bank or migration your cloud workload, this will take months. So how do you think about that? And if you think about birds, they think about seasons, right? We think about quarters, we think about sprints, but it's pretty much the same idea that how we do that, understand what's happening. Third thing is like collaboration with security. If you're a security person, you need to work with engineering. If you're an engineer, you need to work with security. We got this thing in the past that security and engineering was quite of rivals, but as the things evolve, we got more software engineers coming to security and more cybersecurity engineers coming to software engineer. So the main idea is how do you do that together, and then you understand and you get security and software tools to be better. The first thing is pretty much layers provide resilience. Okay, I have this new tool that I bought that told me that we sort out everything about security. That's quite a lie. But how I have these layers and how I can evolve, not have an only single point of failure. And curiosity is guidance, right? If you have cows, monkeys, if you have things moving in the system, I want to understand, I want to see how I can evolve from that, how I can monitor this behavior and evolve. It's a hive kind of ecosystem. We did talk about 9 animals in different ways. Not 9 animals because we got a flock. But the main idea is think about the bee and the falcon. We got the spider, so pretty much the runtime security, fields observability, and then we can evolve on that place. We have birds and otters, pretty much. If I have migration security, I can enable service mesh. So after having this migration with the flock, I can understand how to hold hands and how to be together. We have the armadillo bee plus falcon. It's pretty much I have more layers of defense that right now supports runtime security, for example. We have the spider with others. If I understand my connections, if I understand that I can trust this other holds hands, I can have more observability, I can get more information. And then we have the others and the cows, monkeys. Think about service mesh, this supports threat stimulation, right? If you do not test your systems, if you do not try to break your systems, they are not safe because hope is not a strategy. So pretty much how you can have more cows, monkeys, and others working together to understand if thing is safe or not. And again, sorry. The main idea of our journey today is to understand how these things can teach us about some things. Most of the things that I said here today will be quite simple, and the idea is to be simple, is to bring more people together. But is how you can think about the analogy, right? I know that someone here today will be like, oh, yeah, if I think about BPF, we come a B. Or if I think about service mesh, we come with our. But the main idea is to have how this thing get easy in your mind. As humans, we got this thing of analogies, right? It's quite amazing when you teach a kid or when you have this really amazing linear algebra teacher in university if you did something in the mathematical fields. The analogy brings the knowledge close to you. The idea of the analogy is pretty much one thing that's close, how I can evolve that. So for example, everybody who learned to program see about the algorithm being a bake cake, a recipe for a bake. So you understand the step by step. And the thing we want to hear today is to show that importance. And then when you think about layers, you have this view of animals, and you got this information getting more time in your mind because you're not only using your brain to memorize the information, but to start to do these connections, right? And then it's pretty much about the spiders, right? You have the connections in the web, and you have the vibrations. So as you start to see analogies, how you start to see things that in theory do not go okay with each other, you start to understand. One really good example about that is language. If you speak really 2 different languages, like Portuguese and Korean, even there, they got some words that are quite close. Even they don't have any contact in history, but the main idea is that as humans, we make some sounds and you make some words that needs to be understandable. Because we came from animals as well, right? So the way that the animals echo communicates pretty much thinking about context, so how do we evolve on that way? And pretty much we talk about others and the cows, monkeys. One thing that I quite like is what I was saying about now is, right now you understand that wildlife and cloud security have a lot in common. So we got a lot of systems and think about through that. If you think about telecommunications and pretty much wireless systems, we got one thing that's based on ant colonies. So we got a whole field of computer science that we call bio-inspired computer science. If you look about robots and etc., one thing that the Boston company was doing in the past was like, how do you have animals to do things and you got this kind of skeleton to evolve? So pretty much we are quite close to each other in the end. And I quite like this one because you can only understand what you can measure. So this is a little bit more technical, not thinking a lot about the animals, but every single thing that I told you guys here today, I told you folks today, is how you can measure every single stuff. So if I think about the others, how much of my cells got MTLS? If I think about the spiders, how much observability I have? So I can have this kind of information, I can have this kind of evolution. And there's so much more, to be fair. I got like 20 animals, but it was not too much for that. It's too much for that talk. But then you can think about how do you have the octopus think about, okay, I have a multi-cloud architecture, how I can distribute my tentacles and move. I can think about EIM and penguins, okay, so how I have use things like Okta, OK Cloak, and so on, and then start to have this. And pretty much, when you think about compliance, so the information that we have in the past, how we save that in an easy way, and how we can automate as well. I like to talk about the future. We talk a lot about quantum computing, but even with animals, you can think about subposition and other stuff. We got a really good talk about quantum computing in KubeCon of America, but the main idea is, as we evolve and start to talk about different things, how we can evolve our analogies, how we can evolve the way that we learn. And again, that's kind of the last slide. It's pretty much think and act like animals because we can see this to evolve, we can see this to evolve. So the main idea is, in the rush comes of the cloud complexity, we still need to be others, so we can pick in each other's hands and evolve. I think that's the most amazing thing about this kind of summit, right? You learn new things, you see new people, and I think that's the whole thing behind the open source. And thank you so much. Any questions? No? So thank you for your time.